morning, class. Today I'm subbing for Miss Chivers, and we will be learning about electromagnetism. Instead of lecturing you guys, I have this lovely setup to show you how it works. Alright, I'll just go through our materials, which is 2 soda cans, they are empty, 1 soda tab, a plastic pen. Note that it doesn't carry current because it's plastic. 2 wires, a TV, a tinfoil sheet on the screen of the TV, and an LED light, a steel ring, and copper wire that coiled around it. There are a couple parts to this setup, but the main thing we're going to focus on is lighting this light bulb. So how it works is the TV is plugged into an outlet which has an alternating current, and this current flows through the TV, creating energy or electrons. These electrons are pulled to the tinfoil sheet, and they go up by the wire up to this can. The electrons now from this can makes a magnetic field, which is what causes the tab to go back and forth when we turn. Alright, let's go ahead and start the setup, and I'll show you how it works. Alright, so the TV is connected to an outlet, which gives it an alternating current. The current flows through the TV into the tinfoil sheet that's on the screen. All the electrons and energy are gathered by the tinfoil and taken through this wire up to the can. The electrons now from this can makes a magnetic field, which is what's causing the tab to go back and forth. You can tell that the current is alternating by the back and forth motion of the tab. Like I said before, the pen is plastic, so it isn't doing anything to cause the tab to move like it is. This current continues to carry through the other can and the wire. This wire is connected to a coil around a steel ring. The coil is wrapped around the ring so it can carry the current to the other coil. There is 2 separate coils here. Finally, this coiled wire is connected to an LED light. To make this light actually light up, there was an inducive alternating current throughout this entire model. Now that I'm done showing you the model of how an electromagnet works, take your notes out, and I have some key terms I want you guys to know. One of them is a solenoid. A solenoid is what we use here and here, and it is a cylindrical coil of wire acting as a magnet when carrying electric current. It is very useful to this model, obviously, to light the LED light up. Another is a generator. A generator doesn't create energy, but converts mechanical energy obtained from an external source into energy as the output. We somewhat have a generator from the TV. Lastly is a motor. We don't use the motor in the project, and to be honest, I don't know what it is. Let's call your teacher and maybe she'll know.
Hello?
Hi, Miss Chivers.
Hi.
The class has a question for you. How do motors work?
Hello?
Hi. Can you hear me?
Now I can.
Okay. Well, the class has a question for you.
Alright, what is it?
How do
What?
how do motors work?
Well, the moment that this half turn of motion of an electromagnet, the field of the electromagnet flips. The flip causes the electromagnet to complete another half turn of motion. You flip the magnetic field just by changing the direction of the electrons flowing in the wire, and you do that by flipping the battery over. And if flipped at the right moment, your motor runs freely, and that's how a motor works.
Thank you. soon.
Alright.
Bye. Well, class, looks like it's time. No homework for tonight. I hope you enjoyed our little lesson on electromagnetism. And remember, electromagnetism is the interaction of electric currents and magnetic fields.